Find the stiffness in the table, in pounds-force per inch. In this problem, a table with a rigid top has a natural period of vibration of 0.5 seconds when unloaded, and a natural period of vibration of 0.75 seconds when loaded with a 50-pound force weight. For sake of clarity, we'll refer to these two instances as Scenario 1 and Scenario 2, and use subscripts 1 and 2 to identify the scenario, when appropriate. The general equation for stiffness equals the natural circular frequency, omega sub n, in radians per second, quantity squared, times the mass, m, in pounds force seconds squared per inch. The natural circular frequency equals 2 times pi divided by the natural period of vibration, T sub n. If we plug in the natural period of vibration for both scenarios, the natural circular frequency equals 12.57 radians per second and 8.378 radians per second for the first and second scenarios, respectively. Plugging in these natural circular frequencies into our stiffness equation leaves us with two equations for the stiffness in the table. K, dependent upon mass of Scenario 1 and the mass of Scenario 2. The mass in Scenario 1 is simply the mass of the table, m sub t. And the mass in Scenario 2 equals the mass of the table, m sub t, plus the mass of the weight, m sub w. Since mass equals force divided by acceleration, the mass of the 50-pound force weight on planet Earth equals 0.1295 pounds force seconds squared per inch. Substituting this value into the stiffness equation, we are left with two equations and two unknown variables. Those unknown variables are the table stiffness, K, and the table mass, m sub t. If we set the right-hand side of these two equations equal to each other, we can solve for the mass of the table, m sub t. And after a couple lines of algebra, we find the mass of the table equals 0.1035 pounds force seconds squared per inch. If we substitute this mass into the original equation for the table stiffness, we find the table stiffness equals 16.35 pounds force per inch. When reviewing the possible solutions, the answer is D.